Hello everyone. Here in this video, we'll discuss about various networking devices, their working, applications, specifications, and finally, by comparing all of them, we'll draw a conclusion. Network connecting devices are the devices which are used to connect computers so that they can share files or resources. Now, we'll discuss each of these networking devices one by one. Let us start with a repeater. A repeater can be defined as a non-intelligent network connecting device which receives the signal on one of its ports, regenerates the signal, and then retransmit it. It operates in the physical layer and the location of repeater on a link is vital. Its working is shown in the picture. It receives the signal when it becomes weak, then copies it and regenerates the original bit pattern. After this, it retransmits the regenerated signal to the other segment of the LAN. Repeaters can extend the network physical distance, and this is the very important advantage offered by the repeater. But they cannot connect network with different architectures. They are mostly used for the connection of two different segments of a LAN. Now let us talk about the hub. It is basically a multi-port repeater that connects multiple computers or other networking devices. It operates in the physical layer and it is the multi-port device, which is common central connection for all the devices in a network. There are three different types of hub: active hub, passive hub, and intelligent hub. Its working is shown in the picture. When a hub receives a packet of data at one of its ports from a network device, then it transmits the packet to all the ports of other network devices. They are the low-cost solution and hence a less expensive device. Hubs cannot filter the information and most of the hubs are unable to utilize VLANs. These are some of the limitations of the hubs. They are used to create small home networks and for monitoring these networks. Let us talk about bridges. It is the networking device that connects network segments by analyzing incoming traffic frames and making decisions about where to direct them based on their MAC addresses. It operates in the data link layer and it uses table for filtering the decisions. There are two different types of bridges: transparent bridge and source routing bridge. Routing table is built to record the segment number. If destination address is the same segment as the source address, it stops transmitting. Otherwise, it will forward to the other segment. This working is also shown in the picture. Bridges can extend the network by acting as a repeater and can reduce the network traffic by subdividing network communications. But they are more expensive than repeaters and hubs and operates more slower than them. The most common application of bridge is that it creates a single aggregate network from multiple communication networks or network segment. The next networking device is switch. It is the multi-port device with buffer and a design that can boost its efficiency and performance. It operates in the data link layer and it subdivides the network into smaller segments. Its working is explained in the slide. The switch collects the data to be transmitted and it forwards this data to the appointed recipient. This working can be very well seen in the picture shown. Switches increases network performances, but they are more expensive than bridges and hubs. They are used in small office or home office applications that typically uses a single switch to access the various broadband services. Let us discuss routers. A router is a network device that routes the data packets based on their IP. Router operates in the network layer device in the OSI model. They routes the data to its intended destination, and router ensures that the information does not go anywhere where it is not needed. A router inspects a received data packet's destination IP address. After that, it calculates the best way for it to reach the destination. Then, it forwards the data accordingly. This working of the router is explained in the figure shown. Routers can control different network architectures, but they are more expensive than bridges and repeaters, and they are slower than bridges and repeaters because they must analyze the data transmission from the physical layer to the network layer of the OSI model. They are the basic building blocks of the telecom service provider, and they work as the backbone of mobile networks. Last but not the least, let us discuss about gateway. Gateway, as the name suggests, is a passage to connect two networks together that may work upon different networking models. It operates normally in the transport and application layer of the OSI model, and it is also called protocol converter. The default gateway allows computers on a network to communicate with other networks. Basically, computers send data that is bound for other networks, and this data is received by the gateway. Then it transmits the data to other networks. This is shown in the figure. Yes, the gateway reduces the complexity of the edge services and provides security capability, but the implementation cost of the gateway is very high. The gateway is used in home networks, which allow computers within the local networks to send and receive data over the internet. This is the comparison among the various networking devices which we have discussed: repeater, hub, bridge, switch, and router. The comparison is based on in which layer they are operating in the OSI model, whether there is traffic isolation in the network device or not, what is the cut through, plug and pay, and whether they have efficient routing strategies or not. So, from this study of different networking devices, we can conclude that if we have the solid understanding of these network devices, then we can build a network that is secured and which serves our organization well. However, to ensure the ongoing security, one should monitor his network devices and activity around them so the configuration issues and attacks can be quickly spotted. Thank you.